implemented in our sites. So you have here what we call the burner, the smart burner that we develop in our office in Belgium. And you have two tubes here, two coaxial tubes, the gray one and the white one. So the burner uses a gas or a fuel. It can be natural gas, it can be LPG. In our case, it's kerosene. And the heat produced by the combustion goes down into the inner tube. I'll stop here. So the heat goes down into the inner tube, which is the gray one, goes all the way down. It's open here at the bottom, and it goes up again. And all the combustion gases are collected through this exhaust pipe. Now the heat that is produced inside the tube is conducted into the soil, and the contaminants that are present in the soil and everything that's organic actually, so including water, everything that's organic and water, they go in vapor phase because the temperature reach pretty rapidly 350 degrees and more, and the heat is conducted through the soil. They go in vapor phase, contaminants go in vapor phase, and they are vacuumed through this second pipe here. So this is in negative pressure, and it vacuums all the contaminants, and all the contaminants are collected through this pipe and sent to a vapor treatment unit. So now in this representation, we have only one burner, but if you have a big size, you can have 50 of them, or you can have 100 of them, maybe 500 of them. It just depends how big your size is, and this is really replicable at infinity. So it's really a three-step process: conduction of the heating from the tube, a vapor extraction system, and then a vapor treatment, in this case for dioxin. I'll be speaking about the vapor treatment later on. This is the pilot activities that we plan to do. So you have an ex-situ treatment plan. So it means that the soil is excavated from a zone and put in a pile on site, but excavated. And you can see here we have about 15 burners in this pile. Here you have the in-situ thermal treatment. So it means that we have been drilling directly the tubes into the soil. Here you have, I think, 25 burners. And here in the middle, you have the vapor treatment unit, which I'll be describing later on. So the objective of the pilot was really to prove that we could treat the soil with this technology, and that we could treat the vapors with the vapor treatment unit. In December 2019, we went on site for mobilization. So we brought all our equipment. You can see there, that's the thermal oxidizer from for the vapor treatment unit. So we start building up the pile, and you can see there what it looks like in real. So this is a pile with 240 cubic meter of soil. And within this pile, we have put 3 different types of material, which differs from the humidity. We had dry soil, sludge, and washing cakes. These washing cakes were coming from washing plants, soil washing plants, just next to our installation. And the goal of these 3 materials were to prove that regardless of the humidity of the soil, we could actually treat it in an amount of time that's respectable. So the estimation of time treatment was about 45 days. But unfortunately, after a week of treatment, we had to stop the heating because of the COVID-19 and of the lockdown of the country. So we had to go back to Belgium. And we really hope to get back there once the border will reopen. Hopefully this will happen soon enough. So that's the vapor treatment unit itself. You have here the thermal oxidizer. So all the vapors coming from the pile are vacuumed and brought through this pipe inside the post-combustion, the thermal oxidizer. So now we have designed this thermal oxidizer in order to meet these specific conditions here that need to be met in order to destroy the dioxin. So you need to have a temperature of 1100 degrees, you have to have an oxygen content of 6%, and a minimum resistance time of 1 second in order to destroy the dioxins that are coming from the soil. Once you have destroyed that dioxin into the thermal oxidizer, all the vapors are sent to this quenching tower, which is designed to reduce the temperature really rapidly in order for the dioxin not to reform after its destruction. Because if you would just release the dioxin at 1100 degrees in the atmosphere, it will rapidly reform, and then it will just transfer the problem from the soil to the atmosphere. So we have destroyed the dioxin here, and we ensure that it doesn't reform afterwards by quenching the gases to a temperature of 400 degrees or even less. So with this system, we are sure for the complete destruction of dioxins, and if there is a problem with the thermal oxidizer, there is a backup activated filter, carbon filter here. And of course, all along the vapor treatment units, we have monitoring, pressure monitoring, temperature, and of course, we have measuring points of the concentration of dioxins and other gases as CO, CO2, and so on. This is a graph of the temperature inside the thermal oxidizer. So we have reached the required temperature of 1100 degrees. But unfortunately, after a week or so of heating, we had to stop. So we were pretty happy because it was a challenge to meet these specific parameters and to ensure the destruction of the dioxin, and we did that. And so we're pretty confident to get back there and keep cleaning the soil. So the advantages of that combination of technology with the treatment, the in-situ treatment, thermal treatment, EX-SITU, and the vapor treatment unit is that you don't have any waste, because everything that's coming from the soil, everything that could be liquid is gone into vapor phase and then goes into the vapor treatment unit, and you end up only with CO2 and water. And you don't have any solid, because you could go through an activated carbon filter, but then you would just transfer the problem from the soil to the carbon filter, because you would have contaminated filter with dioxin. So you would have to deal with that still. So with that technique, you just destroy the dioxin once and for all, and you get rid of it. So we are compliant with VAPOUR emission because the conditions at the vapor treatment unit are met. And it's a fast and definitive treatment because we have estimated 45 days of treatment, maybe 50, maybe 35, but it's pretty fast, and it's a definitive treatment because once you get rid of it, it's done. Your soil is clean, and you can reuse it as you wish. Just a few words about our company. So we're based in Belgium. We have our office there, and we have the engineering part. We have the lab and R&D facility where we did the laboratory test for the dioxins, for example. And we have the manufacturing of the smart burner facility. So that's where we do all the maintenance and the manufacturing of. This is really the core business of what we do, the burners. It's been 25 years we're in there, and we have been operating worldwide, as you can see here on the map. We're pretty much busy for now in Europe and in Asia, and we were quite busy for a while in North America. So that's it for me. Thank you for your attention, and if you have any questions, feel free to shoot, and thank you for your attention.
Thank you very much, Joachim, for this very interesting presentation and your creative solution to deal with this large amounts of dioxins polluted soils. It also is a nice example of the immobility of dioxins decades after the Vietnam War, that you still find this high amount of dioxins in the soils. Very interesting. Thank you very much, Joachim. Christiane, can you take over? Please.
Yes, of course. Thank you, Frank. I'm pleased to announce the next speaker, who is Nino Tarantino, who will present us the application of PITO technologies in the experience of landfills in infringement entrusted to the commissioner. Please, Nino.
Okay. Good morning, everyone. I am Nino Tarantino, and I work in the office of the Extraordinary Commissioner for the Illegal Landfills. My short presentation in PowerPoint wants to have a very pragmatic cut. There are various actors, such as research bodies, university, environmental protection agency, and many others, who deal with a very professional and much more qualified scientific and technical point of view. It would be inexplicable if a structure like ours did not exploit this specific and constantly growing know-how. So I want to explain the experience that shows examples of concrete application of phytotechnology techniques on some of the illegal landfills in infringement proceedings, entrusted to the extraordinary commissioner. I immediately apologize for my less than perfect English. I'm sorry. Title is Application of Phytotechnology Intervention in the Experience of Landfill in Infringement entrusted to the Extraordinary Commissioner. I want to briefly illustrate the type of phytotechnology intervention applied in 5 cases, which involved the University of Sannio, ARPA Umbria, ARTA Abruzzo, as well as professionals and municipalities located in various Italian regions, Calabria, Lazio, and Abruzzo. This is the name of the 3 different municipalities in Calabria, Badolato, Petrona, and Villa Latina in Lazio. In these 3 cases, there is a maintenance of the greenery carried out by the municipality and the monitoring of plant species, also as a technique for verifying the successful outcome of the intervention. Thanks to a careful description of the intervention carried out, the sites are under investigation by the administrative offices of the European Commission and will probably come out of the infringement procedure. The 3 projects, with their specific differences, envisage a series of interventions aimed at the final settlement and the environmental restoration of the former landfill. In the landfills, there were already a capping consisting of an HDPE geomembrane with overlying soil of a variable thickness in one case, replenishment of soil only in the other 2 cases, but often this sheet was damaged, incomplete, or no longer suitable. In order to enhance the isolation of waste deposited from the external environment and improve the landscape and environmental integration of the site, in addition to what is already present, a phytocapping was created consisting of 2 main components: the vegetation, which acts as a rain catcher, and the ground is a deposit. Phytocapping performs the same functions as a traditional capping by controlling percolation throughout 3 main mechanisms: the interception of rain by the foliage of the plants, the storage of moisture in the soil, and evapotranspiration. Throughout the planting of vegetation, it is also possible to ensure greater stability of the soil cover protection from erosion, increasing biodiversity and improvement of landscape integration with visual reconnection of the site to the surrounding environment. The planned environmental restoration is configured as a renaturalization intervention, whose main purpose is to establish that slow natural process of evolution towards climax without the need for subsequent intervention. The primary objective, therefore, is to aim for the renaturalization of the site in a reasonable time by restoring a natural environment, an hospitable habitat for the maximum variability of plant organisms. The projects also took into account the need to ensure the best landscape integration of the sites, according to the landscape environmental characteristics of the context in which they fall. The choices were also oriented towards intervention to require maintenance reduced to a minimum. The main purpose of intervention is, from an ecological point of view, to restore its character of continuity to the environment, reconstituting the typical vegetation of the places, of continuity of the environment and the natural microenvironments, which, in addition to a landscape value, have an important ecological purpose to favor the maintenance of local biodiversity. Okay. In conclusion, the planned hydroseeding intervention guarantees, in the first phase, a rapid coverage of the soil with development of mainly herbaceous vegetation, which sequentially evolves towards a shrubby low stage. This association represents an element of connection with the wooded areas contiguous to intervention site. Last important information, the following technical means were from the intervention: glue that favor the adhesion of the seed to the surface on the soil, especially in sloping condition; fertilizer, which being distributed together with the seed favors germination and ensures adequate nutrition to the seedling during rooting; and colonization of the volume to earth. Microbial consortium consisting in mycorrhizae and rhizosphere bacteria that promote plant development and promote its adaptive capability in condition of biotic and abiotic stress. But the less important information is this: the material comes from nursery structures located in neighboring areas, or in any case, comparable from a phytoclimatic point of view to those of the plant, in order to ensure full adaptability of the material to the pedoclimatic characteristics of the place of use. The nursery facilities are equipped with suitable production organization, as well as proven research and experimentation centers in forestry and arboriculture sectors, and a large wealth of technical scientific knowledge and experience. This is to answer an appropriate and targeted experimentation to identify within the various works the optimal genetic characteristics, origin, varieties, cultivars, patented clones, etc., depending on the specific uses. The optimization of multiplication and breeding techniques always aimed of satisfying the intended purposes. All the nursery material is free from parasitic attacks, current or past, by insects, fungal disease, viruses, other pathogens, deformation and or alteration of any nature that could compromise the regular vegetative development and the typical bearing of the species, varieties, and cultivars. Another case is on municipality of San Valentino in Abruzzo Citeriore in Abruzzo region. Thanks to a careful description of the intervention, this site came out of infringement procedure. This case is very particular for this reason. There were overrun on surface soil and of the waters. The intervention of phytotechnology was applied on the recommendation of ARTA, Agency of Abruzzo region, which suggested a project based on constructed wetlands and alternative to the creation of the classic HDPE capping and the upstream drainage trench. To this end, the executing company analyzed the leachate present in the landfill to evaluate the most suitable plant species for the phytocapping intervention. Following phenomena of heavy torrential rains and small landslides, the thickness of topsoil in the planted area had to be immediately increased with a minimum variable between 40 and 50 centimeters. The contribution of ARTA, procedurally and technically, is decisive in this case. The last example of phytotechnology used, more recent and still in progress, typical example where some of the advantages of phytotechnologies are evident. Sustainability of actions, reduced costs, management of marginal rural degraded areas. This site probably come out of the infringement procedure. Revegetation of riparian areas, escarpments, non-arable areas, contrast to the risk of erosion, flooding, containment, etc. Creation of buffer zones with green areas, landscape and ecosystem reconnection. The situation of this site was related to provision information and documentation which have been put into the system. The characterization plan, supplementary and geophysical surveys, and final technical report, data dating back to activity carried out between 2013 and 2017. This is the landscape, this is the center of the municipality. In this context, through the collaboration with ARPA Umbria, in particular with Andrea Sconocchia and Paolo Sconocchia, the work was organized in 3 sectors. 1, inspection and actions on site. 2, technical reports. 3, intervention proposals. Situation found, heaps of waste are not identifiable even is small. Unidentifiable hotspots cannot be excluded from the investigation carried out. There is no effect on the environment, circumstances, soil, water, or atmosphere. The site is still uncultivated and unmanaged and therefore abandoned. Action required. No immediate remedial or safety measures and required. Management measures are necessary to guarantee the existence of the security condition encountered today. Protective measures for the medium to long term. Phytocapping, green technology, coverage for the following objectives. Achieve and maintain geotechnical stability. Regulate the water balance of the site by reducing deep water infiltration. Avoid abuses of the site. Restore a natural habitat in the area. In each of the cases mentioned, in each 5 cases mentioned, a video surveillance system is always provided that can document any unauthorized access to the area, abandonment of waste, or damage of the fences in the area. In addition, every time a landfill is requested to leave the infringement procedure, our office contacts the local carabinieri to carry out periodic checks, and the common factor present in all these cases is the enormous economic savings of the intervention and therefore the excellent cost-benefit ratio. The aforementioned intervention have replaced or integrated different design choices, are subject to monitoring and verification both from the environmental and phytosociological point of view. Many of the landfills of our competence are located in the Calabria region. So the continuous interaction with the regional institutions are in particular with ARPACAL, Environmental Protection Agency of the Calabria region, has led to the scientific direction of the Regional Center for Coordination of Environmental Control and Risks of the Region Agency for the Protection of Environmental of Calabria itself, the publication of important guidelines on addresses for surface coverage of all disposed drains, where briefly the following is established. Some cases different where it's possible to have a phytocapping. And so Main environmental condition for choosing the types of coverage: low criticality ground coverage. Case A, absence of water table. Stabilization, inertization of the waste body. Compliance for the transfer test. Absence of leachate and biogas. Absence of exceeding the reference CSC, contamination threshold concentration. Management and maintenance of the roof. Second case, medium criticality ground covering together with vegetation. Case B1, phytocapping. Presence of exceedances of the reference CSC, contamination threshold concentration, but in any case lower than the SCSR. Absence of water table. Stabilization, inertization of the waste body, compliance of two release tests, absence of percolate and biogas, management and maintenance of the roof. Case B2, phytocapping, ground coverage together with vegetation, presence of groundwater in the subsoil of the landfill, absence of exceeding the reference contamination threshold concentration, stabilization, inertization of the waste body, management and maintenance of the roof. Case B3, phytocapping, ground covering together with vegetation, low degree of stabilization of waste, non-compliance of transfer test, presence of leachate and biogas, but absence of water table, absence of exceeding the reference, management and maintenance of the roof. Case C, height criticality coverage with the waterproof surface, presence of contamination in environmental matrices, leaching pathways in groundwater, low degree of stabilization of the body wastes, management and maintenance of the roof. I am not a technician, but in Italy, there are many technically highly trained people within some public institution. You just need to know how to make the most of their skills. Whenever possible, in my opinion, solution with phytotechnology should always be preferred. Thank you for attention and forgive me for my English. Bye.
Thank you very much, Nino. We certainly forgive you for your English because it was a clear presentation to me, at least. Thank you for showing the possibilities of phyto technologies for landfills, for landfill management. I propose we continue to the next presentation. Jussi, are you willing to introduce the next presentation?
Yes, thank you, Frank. So our next speaker will be Kristiina Makri from the University of Glasgow. And she'll tell us about the use of respirometry for chemical oxidation agent, activator type and concentration selection for saturated hydrocarbon contaminated soils. So please, Kristiina.
Hello, hope you can see my screen. My name is Kristiina Makri and I'm a recent graduate of the University of Glasgow in Environmental Science and Sustainability. And during my industrial placement, I've worked with environmental reclamation services and working with Thomas Asprey, we have developed the following laboratory assay based on the use of respirometry for chemical oxidizing agent treatability testing in saturated hydrocarbon contaminated soils. And to begin with, in-situ chemical oxidation is an advanced remediation technique for hydrocarbon contaminated soils and groundwater, and typically works with the introduction of an oxidizing agent in the saturated ground to achieve the mineralization of organics. Examples of oxidizing agents available for ISCO include hydrogen peroxide, ozone, permanganate, percarbonate, and persulfate. The selected oxidizer is usually combined with one or more activators to promote an efficient reaction. However, oxidizer and activator selection is usually based on contaminant degradation, such as total petroleum hydrocarbon concentration. This is a form of destructive sampling, which can be impacted by sample heterogeneity based on 1 to 10 gram extracts. It also provides non-real-time data, and it can be expensive. In recent years, persulfate has emerged as a popular choice of oxidizer due to its efficiency and comparative stability in the subsurface. Persulfate treatment relies on the generation of radical species with their production stimulated by activators such as UV light, heat, activated carbon, alkaline conditions, and transition metals, mainly iron. Also, natural soil components, including metals and organic matters, phenols and quinones, can naturally enhance the oxidative reaction of persulfate. Aim of this project was to assess the suitability of using an automated respirometer for chemical oxidizing agent treatability testing in saturated hydrocarbon contaminated soils. The approach demonstrated here is based on tests carried on different matrices under controlled conditions. More specifically, clean soil collected from the ERS yard and clean general filter sand was used. The soil was sieved and homogenized, and both matrices were then spiked with diesel and hexane in batches. The matrices were characterized as follows. Both soil and sand had an alkaline pH above 9, with soil's moisture content showing a concentration of 23.4% and organic matter of 0.1%. with a total ion concentration of 50,000 milligrams per kilogram, where diesel hexane spiking produced a total petroleum hydrocarbon concentration of around 4,000 milligrams per kilogram in both matrices. For oxidation experiments, sodium persulfate was selected as the main oxidizing agent to be tested. Ion activation was generated using iron 2 sulfate, and to achieve alkaline activation, sodium hydroxide solution was used. The experiments were conducted in polypropylene tubs, loaded with 50 grams of contaminated soil or sand. The moisture was adjusted for all treatments, where matrices in controlled samples only received water. For oxidation testing, 2 grams of sodium persulfate was added to experimental tubs and followed with the addition of an activator. Iron was used in 3 different molar ratios, and for alkaline activation, the initial pH was adjusted above 10.5. 4 to 6 replicates were produced for each sample and maintained at controlled temperature. A respirometry instrument, and specifically the Respicon automated respirometer, is being used in the Environmental Reclamation Services lab for bioremediation testing. In this case, the Respicon was used to measure carbon dioxide production. The prepared samples were incubated in the respirometer's dedicated water bath, and mineralized carbon dioxide was trapped in potassium hydroxide solution, with electrodes measuring change in its conductance. The records were taken in 1-hour intervals, with the system allowing real-time observation of experimental kinetics. The Respicon is ideally suited for this type of experiments, with a capacity of 96 samples to be compared simultaneously and having sensors not damaged by the high moisture content of the samples. In this experiment, we compared carbon dioxide production of spiked and non-spiked soil with and without sodium persulfate addition. The bars represent the average quantity of carbon dioxide produced by each sample as recorded at the end of the experiment at 35 hours, while error bars show variation between replicants. Here we have observed carbon dioxide release both in non-spiked and spiked soil following sodium persulfate addition. This indicates that the oxidizer had a significant effect on the mineralization of organics. However, oxidative radicals are not specific in the organics targeted, and organic matter has also degraded alongside the diesel pollutants. Here, in separate experiments, we assess the effect of ion-activated sodium persulfate in spiked soil and sand. Firstly, spiked sand, by comparison to spiked soil, produce very little carbon dioxide with or without sodium persulfate, reflecting on the low presence of organic matter. And following the addition of oxidizer in sand without activator, only a small increase of carbon dioxide was observed compared to soil, and this is because sand lacked natural presence of metals, which can stimulate persulfate reaction. Moreover, the results of ion activation showed that the 1:1 sodium persulfate to ion molar ratio produced a higher amount of carbon dioxide than lower concentration ratios and persulfate itself. For sand, ion activation had a stepwise effect with molar ratios of 100:1 and 10:1, both stimulating persulfate reaction at different extents. Assessing alkaline activation of persulfate using sodium hydroxide showed no significant increase in carbon dioxide production over persulfate without alkaline amendment. Therefore, in this particular scenario, we can say that ion activation had a more positive effect compared to alkaline. And in this line graph, you can see the progression of average carbon dioxide production for each sample during the first 20 hours of the ion activation experiment in soil. The molar ratios of 100:1 and 10:1 only shows a small difference from sodium persulfate treatment without ion, whereas the 1:1 concentration had a sharp increase of carbon dioxide production from the beginning of the experiment and continued to achieve the most satisfying results. Even though we have successfully produced data on reaction kinetics, further studies are required for the interpretation of these results. And to conclude, we have demonstrated the use of automated respirometer and specifically carbon dioxide mineralization of organics as a more cost-effective, rapid, and reliable approach for chemical oxidation treatability testing. Automated respirometer has the potential to evaluate chemical oxidation treatments under different matrices, which can provide site-specific assessments. We have also demonstrated that it can support the selection of activator type and concentration for persulfate reactions. And lastly, respirometry systems have the potential to provide information on the kinetics of oxidative reactions and the mineralization of hydrocarbon contaminants, which is a subject to be explored. Overall, we do believe that this approach will provide greater confidence and efficiency in ISCO projects for more successful and sustainable practices. Thank you very much for your attention, and please get in touch for more questions and for any information about the project.
Thank you very much, Christina. A very interesting presentation. It's a quite difficult topic for you. I wish you good luck with rounding this off. This ISCO topic is very complicated, but you did a quite good job, I believe. Thank you very much. It's time to go to the final presentation of this session before we go to the planner meeting. Yusi, is it? No, Christina, can you please introduce the final session, final presentation?
Yes, with pleasure. I'm pleased to introduce Mariangela Venko, who will present us the design of asbestos removal from large-scale industrial site assets. Please, Mariangela.
Thank you. Could you hear me?
Yes.
Okay. Good morning, everybody. My name is Mariangela Venco from Eni Rewind, where I manage the engineering department in charge of decommissioning design. Today, I'd like to talk to you about design of asbestos removal from big industrial sites, showing you 2 case studies in which we apply fluidodynamic simulation during the design phase in order to maximize project sustainability. As maybe you already know, Eni Rewind is an Eni environmental company. Our mission is to recover the value of industrial land and waste according to the principle of circular economy. Of course, the decommissioning is a critical step propedeutic to land reclamation and thus to brownfield redevelopment. Since the idle plant we have to dismantle dates to the 60s, the presence of ACM represents a big issue we have to deal with. Stepping into the subject of my today's presentation, I would like to describe a couple of examples of challenging design of asbestos removal within huge confined space enclosing structure in bad conservation status. First case study I'll show you is about asbestos removal from a HAMON cooling tower in Ravenna industrial site. The tower worked as a heat exchanger and today is out of service. It's made of concrete and 50 meters high. At the bottom, there are 4-meter openings through which ambient air enter. Air exits from the top hole after cooling hot water via evaporation enthalpy. Inside the tower, there is an overall rising flow due to the sum of Simony effect and Venturi effects. While in working condition, the Simony effect is prevalent, since the tower nowadays is out of service, Simony effect is no longer present and the Venturi effect becomes prevalent. And the stream inside the tower become affected by external wind. The internal section of the tower contains hot water distribution pipes made of compact asbestos that are in bad conservation status, partially collapsed. According to Italian law, since asbestos is not friable but shows high level of damage, asbestos removal into a confinement, dynamic confinement is required. A dynamic confinement must ensure that all asbestos fibers stay inside the tower and are conveyed to absolute filters. We analyze several solutions to design the confinement. First of all, an internal sealed dynamic confinement that entails the construction of a scaffold inside the tower, obviously not applicable due to the presence of deteriorated ACM and lack of space for installing confinement system. Another solution should be an external anchored sealed dynamic confinement that entails the construction of a scaffold anchored to the top of the tower. Also, this solution was unapplicable because the tower structure cannot afford the additional load of the confinement system. Another solution should be the external self-supporting sealed dynamic confinement that entails the construction of a huge self-supporting external confinement, resulting therefore not affordable due to a low cost-benefit ratio, too big, too expensive, and too risky in construction. On the right bottom of the slide is shown the solution we choose. The confinement is obtained just using the structure of the tower as a part of a confinement itself, without sealing the top hole. The design idea is to reverse the natural flow inside the tower, conveying flow to absolute filters installed at the base of the tower. We choose this solution because, of course, it's simpler, safer, less expensive, but with a big issue to be solved, the lack of physical containment. To verify the validity of the solution we choose, we use a fluidodynamic modeling software called Fire Dynamic Simulator, a code developed by the National Institute of Standard and Technology in the US, able to solve Navier-Stokes equation through a finite element computational approach. First of all, we defined a calculation domain, red box, and the wind direction, green arrow. The model output show the result of simulation on 3 different reference planes, 2 vertical and 1 horizontal. The mass flow rate across an horizontal section 6 meters high that correspond to the top of asbestos pipes, and wind velocity vectors, and moreover particle tracing tool showing potential leakage of ACM particles from the top of the tower. We ran 4 different numerical simulations, 2 in steady condition and 2 in dynamic condition. First of all, we simulate the flow inside the tower in steady condition, considering the effect of external wind just to calibrate the model. The output is an average upward flow rate of about 120,000 cubic meter per hour. That gives a first idea of extractor sizing. The second simulation shows the behavior of the system in case of sealing the bottom openings. The flow inside the tower starts showing a random direction, but tracer leave the tower during the entire simulation period. As a third step, we introduce into computational model 8 extractors of 50,000 cubic meter per hour each, installed at the base of the tower in a radial position. The overall flow starts to indicate a downward trend, and at a low external wind speed, no fibers leave the top of the tower. But at a wind speed of 1 meter per second, some leakage was observable. As a further simulation, in order to increase the downward flow and therefore limit the release of asbestos fibers, we try to evaluate the influence of the reduction of the top opening free surface, adding flow air barriers on the top of the tower. This last simulation shows that no leakage is detected at any wind speed, making this solution the one we choose for construction, since it allows to reverse the natural flow at any wind condition. The airflow barrier will be very light and easy to install, seals made by reinforced plastic sheets sliding on steel cables. Just to recap, the application of fluid dynamic modelings provide good result for simulate flow condition inside the confinement space, predict the particle tracing of asbestos fibers, optimize the sites of extraction, and demonstrate that low requirement can be fully achieved even without a physical containment. And this innovative approach was successfully shared with the Italian authority. Now I'll show you briefly the second case study, demolition to ground level of 3 huge warehouses in Gela refinery. Built in the 60s to store fertilizer, nowadays empty, out of service, partially collapsed, and in precarious state of conservation. The surface they occupy is almost 3 hectares, like 4 football fields. The fertilizer warehouses are made of concrete, arch-shaped, one next to the other, almost 200 meters long, 35 meters wide, and almost 20 meters high. Since the plant was abandoned for decades, as shown in picture, structures are heavily damaged, and for safety reasons, the access is denied. Due to the risk of collapse, corridors between warehouses are unsafe too, and the access is denied. Investigation performed to discover the presence of HEM during the design phase put in evidence the presence of friable asbestos in waterproofing layer covering roof and buttress. According to Italian law, since asbestos is friable and shows high level of damage, asbestos removal into a dynamic confinement is required. Given the situation, the design has to make into consideration regulatory constraints and technical limitations. First of all, structural decay makes it impossible to remove HEM before demolition. Therefore, demolition needs to be performed adopting the same precaution needed for asbestos removal. Moreover, the structural instabilities does not allow the use of a standard confinement linked on warehouses, requiring therefore to design a self-supporting dynamic confinement. We analyzed several solutions to design the confinement. First of all, a confinement enclosing 3 warehouses, entailing the building of a self-supporting single-span marquee of about 120 meters wide, obviously very, very difficult to build. Then a single warehouse dynamic confinement, still too big and difficult to manage in terms of dynamic confinement. And at the end, the solution we choose is the confinement of half warehouse with a marquee sliding on rails lying parallel to the long edge. Chosen because, of course, it reduces the volume of confinement and the adoption of structure sliding on rails allows to reduce assembly and reassembly works. As I told you before, the corridors between warehouses are currently inaccessible due to the risk of collapse. In order to guarantee safety during installation of rails, temporary reticular protection will be installed by the use of a crane. Once protection will be in place, we will proceed with the construction of foundation and installation of the rail for marquee translation. The confinement structure will consist of a steel reticular frame with an arch shape, 150 meter long, 36 meter wide and 23 meter high. The marquee will be assembled and covered by a double sheet layer in a free safe area in front of the existing building and then pushed on rail with hydraulic jackets. Once in place, the confinement structure will be equipped with extractors, personal equipment and material decontamination units. Finally, demolition will be performed inside the confinement space. Similarly to the case of HAMON Tower I told you before, given the huge size of the confinement, also in this project we have implemented the fluid dynamic modeling in order to check the effectiveness of containment, check airflow condition in a working area, and the site's properly extraction system. The visual timeline shows a project schedule that will last 6 years. In conclusion, technical approach for HEM removal can be optimized through the use of fluid dynamic modeling, allowing to manage challenging projects where a standard approach would result not applicable or at least very expensive. As we saw in the case studies, fluid dynamics not only allows to demonstrate that legal requirements can be fully achieved, but also leads to a significant increase in project sustainability in terms of cost, health, safety, and overall environmental impact. Thank you.
Frank, your microphone. Frank, we didn't hear what you say.
Yes, I think I unmuted now. Eh?
Yeah.
Thank you very much, Marie-Angela, for this exciting presentation. It reminds me a little bit on Chernobyl with this confinement. So it's also an exciting study. A great presentation. Thank you very much. Moreover, I like to thank all presenters of this session for keeping the time schedule, because we are perfectly on time, even 5 minutes before schedule to start the panel discussion. I have a few questions myself. Actually, I have a lot of questions myself. But first, I like to ask my co-chairs if they have questions. And also if there are some questions from the chat that are important to include in our panel discussion.
There are 3 questions from the chat. The 3 are for Joachim. I propose that we begin with these questions.
Please, yes. Can you mention them?
Yes. So the first question is from Robert Wegenfeld. I'm sorry for the pronunciation. And Robert asked what happens with the combustion gases. Is that combustion's complete, and do you have an idea how much CO2 is produced from both the combustion process and the thermal oxidation process? And then the second one is from Melanie Heikoy. Melanie, who asked, do you have any study on how the soil can be reused valuably after such high temperature treatment? I propose Joachim can give the answers to the questions to all the participants.
Yeah, thank you, Christian, for the questions, and thank you, Robert and Melanie. For the first question, so what happens with the combustion gases? So they are all collected together thanks to exhaust pipe, and they are sent to the atmosphere. But now each burner can be regulated and can be checked for combustion, for complete combustion or not. So each burner is measurable, and we do it actually. We measure the stack, and if we see that we have a problem of emissions in the stack, we can measure each burner. So that's one thing. And then second thing is that if we have problems, we have activated carbon filter at the end of before the stack, and we can switch from one to another in order to make sure to not to send COs in the atmosphere. Now for the CO2 numbers, I don't have them here, but we have I know it's calculations that we do, because you have the fuel estimation, the consumption, and then with the equation, you can have the numbers of CO2 that you're producing. But yeah, as I said here in the comments, we are usually using about 25 cubic meter of natural gases per ton of soil to be treated. And your question also asked about the quantity of CO2 per kilogram of contaminants removed. I don't know neither, but specifically for dioxin, it wouldn't be a relevant number in my opinion, because dioxins is really in low, super low concentration. So the number of CO2 per contaminants removed will be high, but these are all numbers that we can run. And for the second question about the study of the soil, I know for past projects, for example, we had a big project in Congo, that now the soil that we have been treated is recolonized by a forest. So now they're growing a forest on that. And I know we have a big project in the refinery of Gela, about which Marie-Angela was speaking about. And there, on the first batch that we have been treating last year and the year before, we have already plants growing on the soil. So it's really rapidly recolonized by living organisms. And here at the lab, all the dirt that we have cleaned, we use them to grow plants in there. So we don't have actual studies, but from field experience, we know that it's quite quickly recolonized with microorganism and then plants, trees, and so on. I hope that answers the question.
Yes, and there is a last one on the chat also for you, Joachim. The question is, how large is the area could this in situ heating sticks control?
I'm not quite certain to understand the question, but if the question is how big can the area be with this technique, actually, as I said, we use one burner and one tube has an area of effect of about 2 meters around it, and then depending on the depth that you have, it can go up to 50 meters depth. So what we had in Vietnam that I just presented, the tubes were 12-meter long, and so each tube was treating about 18 cubic meter of soil in this specific case. But of course it depends on the length of the tubes.
Okay. And when when the treatment is in situ, how do you ensure that there is no dioxin emissions to the air?
Well, we drill all the tubes, and then we make sure that it's airtight with concrete slab. It's also for temperature, okay. Because there is a negative pressure in the soil with the vacuuming of the vapor pressure, we are monitoring the pressure in the soil, and if the pressure is negative, we are sure that we vacuum all the fumes that could go out from the soil. So that's how we do it.
Okay.
And it would smell if there is any leakage, and it doesn't smell.
If I may continue with a question to Joachim, now we with you, Joachim. You mentioned a acceptable concentration, when I'm not mistaken, of 630 nanograms a kilogram, which is quite high, to my opinion. What is? I understand you have a mega problem to solve, so maybe that's acceptable, or? But what's the basis of that value? Do you know that?
Well, that's the government regulation of Vietnam on dioxins level. I mean, it's their level that they have set for industrial use, as you've seen on the graph. It's not acceptable for urban area. So that's actually indeed higher than what you could have for urban area. But these are regulations numbers.
You don't know the basis of it.
I guess it's risk assessment analysis, but I don't have the details of how they put the threshold value.
Okay.
No.
And it means that this value only holds for industrial land.
Yes.
Okay.
But the thing is that in the lab test we have heated for 5 days, but actually you could heat for longer and get lower concentration. Now that was all planned for the treatment. What we do actually is during the treatment, while it's still ongoing, we do samples in the soil that's heated, and we can analyze, we can know the concentration of dioxins in the soil. And once we know this concentration is low enough according to the target, we can stop the treatment.
Okay, thank you.
You
see, maybe you have a question?
Well, thank you. Yes, well, maybe I start with asking yet another question from Joachim. In your example, you had piles of the soils that you were treating, but you said you can also treat the soil in situ. So, in your experience, is it if you have an option to excavate and treat the soil on site, which I would guess you could maybe better control. So is it always, can you do it, is it controllable enough in situ, or if you have an option to excavate and treat it on site with the equipment, how would you do it in general? And is it a lot more expensive to do it in situ, or when you have to excavate it?
Yeah.
How do you see that?
First of all, everything that we do is generally it's on site. So even ex-situ, we excavate and then we do that on site because it doesn't take so much place if we have it. and then to decide, how do we decide if it's in situ or ex situ? That's basically your question, is it?
Yes, more or less. Or if you have an option to excavate it and treat it on site, is it preferable? Can you control the system?
Yeah. Well, both system works the same way. It really depends on the depth, because, for example, if you have shallow concentration or shallow contamination, you would excavate, because it's cheaper to have longer tubes, because you have one burner for bigger amount of contaminated land. If you have a water table, for example, you would prefer to excavate. But then if it's dry and if it's deep, or if you can't excavate, for example, because that happens in many times. For example, we're working in basement or in urban area where you can't excavate, there you would go for in situ. But if we have the choice, economically, it's often more cheaper to do it ex situ. But it really does make sense in certain cases to go for in situ. And it's also less disturbance, because you don't have excavations, you don't have trucks there, you don't have dust. Really, the in situ one is it's no noise, no smell, no dust, and that's a really neat technology for specifically for basements and for urban area.
Yeah.
Okay, not too much pressure on Joachim for the moment. I'd like to move to Hugo for a question. Please, Hugo. When I see your contaminants, you have quite some nasty contaminants in your list, and also quite high concentrations. I would be the most worried about leaching to groundwater. Can you tell me, I think you use a screening value that covers leaching. Can you maybe explain a little bit why you conclude that the leaching is safe in your situation? What is the basis of your screening value for leaching, for example?
This was based on leaching tests on the material, where we had actually some exceedings, but I didn't explain all the process. We had some exceedings, but this material is going to be confined in the green barrier and will be treated a bit different. So there is no problem for leaching because of that. And we had also monitoring wells, and there was no detection in the groundwater of this possibility of leaching element.
How deep is the groundwater table?
The groundwater table is about 20 meters deep.
20 meters, okay.
Yes,
okay.
So it's deeper than the buried level.
Mm-hmm.
There is no migration.
And you also measured it, you checked it. You checked
yes,
it.
Yes,
okay.
in groundwater wells, yes.
Okay. Any other questions for Hugo, Christiane, or you see?
Well, I could ask something. Well, first of all, thanks for the excellent presentation. I think it really showed your example how reuse of excavated soils and wastes in general can be beneficial for the whole project. And it was excellent to see the figures you showed about the CO2 reductions and so forth. So maybe my question is more from the general viewpoint, is that how easy would you say it is, for example, in Italy to reuse excavated contaminated soils and other waste materials? And did you have to struggle with the authorities, for example, in this case?
I would say that normally in Italy it's very difficult to do that. But it depends from the local authority. And we are in South Tyrol, Bolzano, and we have a very good relationship to the authority, and is a strong collaboration, because we are building this project since 20 years almost in the design phase and in the construction phase. So we have been facing a lot of issues together with the authority, not only for remediation, but much more for the excavated soil. We are, with our project, we are excavating about 20 million of cubic meters, and there can be a lot of problem in contamination, natural and artificial contamination of the soil. So we have a very good relationship, and it was quite easy to find this solution together with the authority. But I don't think it's everywhere like that. Sometimes it's very difficult, and often is preferred to bring everything to the landfill, which is the worst solution, I think, for a waste which is almost inert.
Not very sustainable, at least.
No, exactly. Yeah.
But I have perhaps questions always about this reuse of materials, of polluted material. Do you have to survey the groundwater mid-term or long-term to be sure that there is no problem, for example, with antimony that is quite soluble pollutant?
So we are going to survey all the area for the next 10 years for generally for our project. But we didn't have a prescription from the authority to survey because of this putting in safety of the site. So we have a big monitoring network, which we are surveying normally, not because of this remediation project, but for the whole project. So we are going to do it, but it was not an authority prescription.
In the meantime, there is a question for Christina on the chat. Christina, can you read it yourself, maybe?
Yeah.
It's about...
It's about the use of potassium hydroxide for the collection of carbon dioxide. The produced carbon dioxide is collected by potassium hydroxide solution, and then electrodes in the solution automatically produce the measurement of carbon dioxide produced by the sample tested. And we don't have an exact idea about the degree of error, but we had a great number of samples. We had 4 to 6 samples, and we did produce error bars for our analysis, if that covers the question.
Okay, thank you. And I have a more or less philosophical question for you. Well, not really philosophical, but I think you did most of your experiments in the laboratory, is that correct?
Yes.
It is, of course, very important to bring this into practice in the future. What would be the most important bottlenecks you believe when you apply this whole ISCO procedure into practice for big contaminated sites? What could be the bottlenecks? What problems do you foresee?
We have already tested, we have got samples from an actual contaminated site, and we have tested that on the respirometer, but we didn't have many samples to get reliable results. And the main issue with that would be the variation between samples. That's why we started with control conditions spiking soil. And yeah, I think that's the main issue, and maybe higher amounts of contamination in the soil might produce problems.
And what could you do to make ISCO more efficient in big practice cases?
Using this technique would be easier to have more efficient measurements of the amount of the oxidizer to be used and the activators to be used, not to damage the biological nature of the soils.
Mm-hmm.
That's very important. So
Yeah, I can imagine. Yes, thank you very much. Any other questions for Christina? If not for the moment, we can skip to Mariangela. Any questions for Mariangela? If I may start for Mariangela, it's exciting, this study, very exciting, a lot of questions actually. One of them is, you mentioned several times friable or non-friable, Mariangela. Is that important for your containment studies when you, isn't that too much detail? And how can you tell when it's friable or non-friable? It's a matter of time. Every bound asbestos become friable in the end.
For Italian law, you have to confine into a dynamic confinement when asbestos is friable or compact, but with high level of damage. And we discover the status through analysis. So the first step of our decommissioning design is always a pre-characterization analysis. So go to the site and take some sample of what we think it would be asbestos. And through the use of a laboratory, we discover if it's compact or friable. Mm-hmm. And if it's friable, we have to confine and use extractor. It's mandatory to do that. And always, if it's compact, but damaged. If it's compact in a well status of, in a good status of conservation, we can remove it without a physical containment.
Mm-hmm. And I saw some former presentations about asbestos in Italy. And I believe that you also make a difference between amphibole and chrysotyl asbestos in your law. Isn't that the case? You didn't mention the types of asbestos in your presentation.
Yes, in the first case, the HAMON cooling tower, we have distribution pipes made of compact asbestos. And in the second case of warehouses in Gela, we have friable asbestos.
Yeah, but I'm not talking about bound asbestos versus friable asbestos, but I'm talking about the type of asbestos, chrysotyl fibers or amphibole fibers. These have a different potency for carcinogenic compounds. I think that's also in the Italian Act that you have to make a difference. Or not? Maybe I'm wrong. Maybe
I think not, because the prior characteristics is the friability.
Okay. Okay. Any other questions for Mariangela?
Yes, perhaps from my side. Mariangela, do you consider other pollutants of this building when you consider the asbestos treatment or for the deconstruction?
In the first case of our design, we try to discover all pollutants. In this case, the principal issue was the asbestos.
And Mariangela, a very practical question for the second case you showed. You, in the end, you confine half of the construction of the first building. That seems very efficient to me. then my question is, why don't you just confine 10% of the building and again shift it along the rail? That would be even cheaper.
Yes, good question. Because it would be impossible to close the confinement. We choose to confine half warehouses because just in the middle of the long side of the building there is a transept that is perpendicular to the long side of the building, and that is such a natural close of our construction. So we can use the transept with the use of a scaffold. We will build a scaffold over this transept to close our confinement.
Mm-hmm. Okay.
So for a structural reason, at least.
Yeah. And I'm also very curious, what will happen with the site in the future? I mentioned Chernobyl. Will it also be like a kind of Disneyland that people can visit and etc.? Or what will happen to the site?
We decided to confine it was a precautionary choice by Eni because due to the instability structure of the building, they can collapse. So we in the design phase we chose to confine to avoid the dispersion of fibers. It's a precautionary choice.
Ah, okay. Yeah, yeah. Any other questions for Christina? And also the audience can ask questions by chat. Any more questions for Christina?
Well, I could quickly ask from Mariangela.
Yes.
So something about the modeling. You mentioned that it was very useful in the project that you presented. Is it something that you often use? Do you use that type of modeling when you are dealing with asbestos in a demolition projects, for example, tearing down buildings? And how can you use it in other types of projects? And when you've carried out the actual work, have your measurements and has the situation complied with your modeling results?
Yes, actually, we used this modeling only in 2 projects I show you, because it's a new introduction in our engineering. So at the moment we use it for these 2 case studies.
Okay, let's skip to Nino. Nino, I have a more similar question as I had before to Hugo. The phyto technology that works out fine, I understand from your presentation, but again, I'm a little bit worried about leaching. The layer of soil and the plants on the soil cannot avoid that rainwater is infiltrating and contaminants leach towards the groundwater, I believe. Can you tell a little bit about the risks of leaching in your case? Are you still there, Nino?
Because in one case, the photo are only the beginning of the intervention. And so for, in my opinion, there are only a simulation before and after 1 year and after 8 years. Sometimes there are a lot of rain, and it's possible when the plants are in the beginning of phases, it's possible to have some damage, and so we must to take another level of the soil, and so it's possible to have an intervention more perfect. I'm sorry, but my English is not very well, and I have more difficult to explain the problem, technical problem and procedural problem. But I think in my experience, I think that phytocapping is very good when there are the situations without a critical problem, environmental problem, when is possible the phytocapping is more is preferable, is okay, because the effect of the foliage of the plants in general is very good, and the effect is more best because when there is the normal HDPE capping, there are a lot of problems, and phytocapping is the best.
Yeah, but I believe that phytocapping has a lot of advantages, but still my problem is that when you have phytocapping, water is still able to intrude into your landfill. And the water that intrudes into your landfill will leach out contaminants. We see that in my country, in the Netherlands, we have our shallow groundwater tables, but we see a lot of leaching is usually the major problem in landfills. So did you check your groundwater under your landfill? Or is that not what you did in your study? Do you understand my question, Nino? Is that
So and so?
So
if you can repeat, please.
Yeah, it's about if you do phytocapping, the rain is falling on the landfill, is infiltrating through your layer of 40 to 50 centimeters of soil, and leaches down, brings down contaminants to the groundwater under your landfill. We see that in the Netherlands. That's a problem in the Netherlands. In the Netherlands, we have shallow groundwater tables. Might be a difference. So I wonder, in your situation, what happens with your groundwater under your landfill? Do I make myself clear, or is it still difficult?
Normally, the condition of the soil in the sites where there are the phytocapping are no more critical normally, and normally there are a typical type of soil where is very difficult to have the infiltration of the water with contamination, and so is very improbably that there are a possibility that the contamination enter in the soil and after in the water.
Mm.
But normally, when there are a good numbers of the plants, there are three level of the stop of the infiltration: the foliage, the plants in general with the with I don't remember the terms in English, and the soil have
I think I know what you mean. Yes.
and so
Frank.
Yeah.
Frank.
Yeah.
Sorry, just to add something to what Nino just said. In general, many landfills does not have are very small amount of waste. They don't have real problems of groundwater, and there is, however, the groundwater monitoring well at down gradient. So we also collaborate as ISPRA to the commissioner, and sometimes there are some landfills that are under infringement but are very small, and yeah, in that case maybe the infiltration is not a problem. And however, as Nino said, we have they have a long monitoring time, so in case that some problems will arrive, they will go for another intervention, because Nino didn't tell that Italy is paying a lot of money each year. I don't remember, Nino, how much is, but for around 100 landfills. And I want to stress the importance of the activity of the commissioner in putting in safety all those situations. Thank you, Nino, and thank you to all your team to do so.
Okay, thank you, Michael, and also Nino for this clear explanations.
I've taken the role of the timekeeper.
Yes.
I think the room will close in 3 minutes.
I know, yes. That's,
okay.
I just wanted to say we have time for one final question when anybody has. One final question, the last chance we have for this session. Jussi, Christiane, or maybe one of the speakers has a question. I don't think there are. Okay, I think then it's almost time. We have 1 or 2 minutes. It doesn't make sense to raise other big questions. I think we can close the session now. I'm very happy with this session. We had some great examples of, I started to say big, we're dealing with big sites here, and that's always spectacular, and we saw some great case studies. Thank you very much, all the 5 speakers, for this contribution. And let's take a break, and I have to announce the next session that will start at 1 hour, in 1 hour, at 14:30 Central European Time. And that is on another great topic, groundwater remediation. I hope to see you later at the Remtech sessions. Thank you very much also to the audience, and have a nice break. See you later.
Thank you very much.
Thank you, Frank,
See you. Thank you, everyone.
Bye-bye.
Bye-bye. Bye-bye.
Bye-bye.